Hello, everyone. Good evening, good afternoon, good morning, whatever time zone you are in. A very warm welcome to our monthly MLflow meetup or virtual meetup today. My name is Jules Damji. I'm one of the developer advocate here at Databricks, focusing on open source. And joining me today in the background, you can't see, is Carly, my esteemed program manager, who does all the particular magic. So we can come to you live on 4 different platforms, including this one, X, LinkedIn, and YouTube. And my esteemed speaker today is Samraj Murjani. I say hello, Samraj, to the community.
Hey, folks. Nice to meet you all.
And he's going to be talking to us about his recent contributions to how you can actually develop agents using the Cloud Code SDK client. And Samraj is one of the contributors of MLflow and also a software engineer in the MLflow team. And he's joining us from San Francisco. And pretty shortly, we will have somebody from Japan who's going to be joining us for the second half of the talk. Now, just a bit of logistics. We can't hear you, so you will have to somehow use the chat to ask us any questions. If you do see anything that you feel the slides are not being visible or the audio is off, do let us know in the chat. But more importantly, we want you to somehow tell us where you're hailing from, if you're from different part of the world. And secondly, are you a practitioner or are you using MLflow? So we just want to gauge an idea of who you are, and that way you can ask the questions. We know who it's coming from. And having said that, we actually have a good program today. Today's agenda, as I said, it's actually quite important to have a very thriving community. MLflow has been having a thriving community for a long time. And daily or weekly basis, we have people contributing, we have people asking questions, we have people posting about it. So there are ways that you can actually somehow engage yourself and be part of the community. And we do appreciate that because it takes community to really make any successful open source project. We have 2 presentations today, the Cloud Code agent SDK tracing that Samraj is going to cover, and Yuki Wanatabe, he's going to be talking to us about the open telemetry support for MLflow via tracing. So that's going to be our second talk. How do you actually get involved? How do you actually get involved with the participant community? There are various channels that you can actually use to talk to us, to engage with other people with similar background. You can join us in our MLflow Slack channel. We can file issues or file PRs in the GitHub we have. We also have monthly calendar events on Luma that you can actually follow and subscribe to our weekly or monthly calendar events that we actually have. We have the LinkedIn MLflow page that you can actually follow with blogs, updates, discussions. And we also have our X MLflow channel that you can actually subscribe to as well. And then last but not least, go to a particular website. So those are the ways you can actually engage yourself with the community. The second bit I wanted to announce that a week from next week, we're actually having or hosting our MLflow office hours in the APAC time. So if you're living in the APAC region, please do join us. We'll have 2 committers from the MLflow engineering team who can answer all the questions you actually have about MLflow, both about the traditional MLflow features as well as the Gen AI features, which are part of 3.6, which was landed last week. So do join us next week. And with that, I'm going to hand it over to Samraj, who's going to talk about Cloud Code Client SDK, how easily you can actually build agent models and evaluate them. So Samraj, take it over.
Cool. Yeah. Thank you, Jules. Super excited to be here and talk about the Claude Code SDK. And bear with me here. This is my first time on this platform, so I'm going to maybe mess up a little bit. But just to reintroduce myself, my name is Samraj. I'm an engineer at Databricks and also contributing to MLflow. And again, I'm going to talk to you guys about Claude Code, Claude Agent SDK, and how we trace those in MLflow and some of the really cool things you can do once you have those traces in MLflow. So I want to preface this by saying, like, I assume a lot of this audience is filled with developers, and in the last couple of months, maybe year, coding agents have become a major part of our workflow. Personally, for me, like, I use Claude Code daily and use it for all sorts of things, whether it's writing boilerplate or unit tests to even doing more complex designs. Personally, I came up with like workflows to go from like a Jira ticket into a fully fledged PR for my smaller tasks. And I love using these coding agents to kind of iterate and design on larger tasks. So they're super, super important nowadays, but as good as they are, they're far from perfect, right? And I'm sure we've all kind of noticed issues in these coding agents, whether it's redundant tool usage, they love reading over the same context over and over, repeating poor coding practices, um, or just generally forgetting instructions that you tell them to do, and maybe making assumptions that they shouldn't make. Um, and there are mechanisms that are provided to close these gaps. For instance, in Claude Code, my preferred one, you can implement different types of memory, whether it's user memory or project memory. There's also Claude Skills, which was released recently. But in general, it's really hard to kind of figure out how to fix these coding agents without actually knowing what's going on under the hood. And most of these coding agents have some UI where you can, see what's happening. But it tends to go by pretty quickly. And, if you're like me and you leave it on in the background, you don't really pay attention to the intermediate steps. So it becomes even more important to kind of see what's happening. And so that's why we've introduced the ability to trace Claude Code in MLflow. If you're not familiar with tracing essentially allows you to see step by step what's happening inside your agent. And you can really easily enable it by just installing MLflow and running this in your command line. So it's just this MLflow autolog Claude. And you can optionally specify additional sort of parameters that you might need, like the tracking URI or the experiment ID. But in this example here, I'm able to actually, once I've enabled this tracing for Claude, I can actually see traces flow into my experiment. And actually, I think the GIF here is not working, so maybe I'll share my screen just so that you guys can see what I'm talking about. So give me a second here while I share.
Yeah, thank you. I think the animation, we forgot to tell you the animation wasn't working. So
cool. Let me pull up the presentation really quickly and share my screen. Here we go. Share this guy. And Jules, can you see this?
Yes, we can.
Amazing. Okay, great. Back on the presentation. Okay, so as I was mentioning before, you can basically enable tracing with this simple command, MLflow autolog Claude. And once I've enabled traces, as soon as I type in Claude into Claude Code CLI, I can actually see these traces flowing into my experiment. So here, an example is I've asked Claude Code to read through my code base and summarize the features. And I can see step by step the different LLM calls and tool calls that Claude Code makes, and I eventually see the final result. And this is super cool because I can actually now understand what's going on under the hood. I've popped open Claude Code, and I can track different things like token usage and cost and other sort of operational metrics, in addition to being able to see what's happening. So this is something that we've introduced. Another thing is this is kind of a sneak peek. I don't know if we've actually released this yet, so it might not be a sneak peek anymore, but we're working on basically making conversations. So each trace in your experiment is kind of like a single turn, meaning the user says something and an agent or something says something back. But if you want to see, a user says something, agent says something, a user says something, similar to what you see here, you need a conversational view. So this is kind of what we've introduced in MLflow in the sessions tab. And you can see here actually the back and forth that I have with Claude Code, and you can actually dive deeper into the individual turns and see what tools Claude is calling at each step. So this is another really cool UI that you can use to kind of understand what's going on under the hood. especially at a conversational level, which is way more common with these coding agents. Now, I'm going to take a step back and kind of get a little philosophical. What is a coding agent, right? At the end of the day, a coding agent is really just a system prompt. This is kind of like its directive of what it should be doing, a agentic loop, and access to different tools and MCP servers. And actually, this last point is what makes tools like Claude Code so powerful. Sort of the ability to use Bash to read and run commands and write code, as well as other integrations you might have with like Jira and GitHub and other developer tools. This makes the coding agent able to do a lot more than just a read-only agent, or kind of the predecessor, which was just retrieval augmented generation. And if you kind of squint your eyes and like turn your head a little bit, you'll kind of see that a coding agent isn't so different than a generic agent, right? You still have your system prompt, you still have your agentic loop, and you have access to all of those tools and MCP servers, whether it's maybe a vector store of documents or sort of APIs that you've created yourself. And the point here that I'm trying to make is that coding agents actually provide the building blocks for really powerful agent frameworks. And what I mean by this is, and I'll make this kind of concrete by saying, like, when I use Claude Code, I can actually change the system prompt through the memory. I can change the tools it has access to, and I can actually build sort of my own generic agent. So in this way, coding agents are the building blocks. And the reason that this is so important, and I'll start with a personal anecdote. Whenever I tried and create agents with other sort of open source frameworks like LangChain and LangGraph or other kind of alternatives, I realized that I was spending a lot of time coming up with this agentic loop, making sure it works, debugging. And this is really important for production grade software, making sure that you have something reliable. But when I actually just have an idea that I want to prototype really quickly, it doesn't make sense for me to spend days or weeks or months on infrastructure when I really just want to prototype and validate my idea. And this is something that Anthropic has made super easy with the Claude Agent SDK. The Claude Agent SDK essentially allows you to write Python code to interface with Claude Code. And so you get that really powerful agentic loop, as well as the ability to access your tools and your system prompt and kind of modify those as you need to build a super powerful agent out of the box without any configuration in just a couple lines of code. So in this example here, I actually defined this, this Claude agent options, and what I've passed into it is an MCP server. I also defined this MCP server through the Claude Agent SDK. It's also just another couple lines of code. I've specified what tools my agent should have, as well as a system prompt for the agent. And I've just passed this into the Claude SDK client here and queried it. And I'm actually able to interface with a really, really powerful agent. Now, the cool thing is MLflow actually allows you to trace this as well with one line of code, MLflow Anthropic Autolog. And when I insert that line of code to the top of my file, I'll automatically get everything traced. So in this GIF here, you'll see an example where I have my travel agent, and I asked it to search for round trip flights. And you can actually see here that it's able to see the step-by-step execution of the Claude Agent SDK. You can see it actually called that search flight tool, and it presented me with a set of results of all the cheapest flights towards the end here. So you can see all the best flight options. So in this way, again, I'm able to pop open that hood and really see what's going on in this agent. And I want to talk about why this is really, really powerful, right? Because even if I have this observability, which is critical for kind of debugging agents and understanding what's going on, there's still this additional kind of question in my head of how do I actually make sure that when I make a change to my agent, maybe I made a change to the system prompt or added a tool, how do I make sure I've systematically made my agent better? And how do I make sure I haven't regressed in some other area or, caused issues, this is where MLflow's evaluation comes into play. So I'm going to take you through an example with the same travel agent. Here I actually asked the question, what are the best restaurants in Tokyo? And I've essentially, I was looking through a couple of traces, and I found that in a lot of these traces, I have a lot of retriever calls. I actually noticed that the latency was pretty slow. It's like, it says up there, it's like 24 seconds. My cost was getting pretty high. And so diving deeper into these traces, I see these 3 retriever calls. And as I look through them, I see that a lot of the queries are very similar. And I don't see a lot of sort of like differences in the results. So they seem pretty redundant. And I could personally go through and try and fix this myself, maybe test it again on the same query. But then those questions of, did I actually systematically improve my agent? Did I regress anywhere? Those questions come up again after I've made that change. And the way that we kind of validate against it is through systematic evaluations. The first step of which is to kind of define an evaluator. And this is essentially what will be, it's more commonly known as LLM as a judge or judges. It's essentially what will be kind of evaluating your trace to make sure that it matches the behavior you expect. So in this case, the bad behavior is the redundant retrievals. And I want to make a judge that catches these redundant retrievals, right? In a lot of like frameworks and typical solutions, what you have to do is you have to write this complex trace traversal logic that takes the trace, picks out all the retriever spans, and kind of figures out, okay, is this trace, or asks an LLM, is this retriever span redundant with this other retriever span? And you kind of have to worry about prompting and figuring out like what context to feed in. It's typically a pretty complex process to define these really complex judges. But with MLflow, we've made it really easy with this make judge interface that was released, I think, in 3.4.0, in which I can define this make judge. I can give my judge a name. In this case, I'm calling it retrieval redundancy. And I can give it a set of instructions on what it should judge. So here I've said, analyze the trace to check if there are redundant retrievals. And we should look at the source IDs returned from the retrieval tool. If there are no redundant calls, return pass. If there are, return fail. This is a very simple judge, and it's extremely powerful because it replaces all that complex traversal logic and all the sort of complexities that I had before with just simple plain English. And the power here is actually in this trace parameter. We're not actually like substituting in the entire trace here. This is actually an agent as a judge. And what I mean by that is we give the judge a bunch of different tools that allow it to kind of introspect on the trace and figure out which spans it needs to look at and pick context out of those spans in order to do the judgment. Okay, so I'm just going to quickly recap what I've said here. I have an issue, right? I have redundant retrievals in my agent, and I want to be able to catch these issues and make sure that when I make a change that I've actually, fixed this issue. So this is my way to catch the redundant retrievals. And the way that I'm actually going to verify my fix is by running evaluations. So when I run an evaluation, all I have to do is specify a data set. This is, a set of traces that I might have, as well as the sort of travel agent that I have. So this is the predict function. It's essentially just running a travel agent. And my scores. So the redundancy judge I just created, as well as I created this other metric called number of retrieval calls. All this does is counts the number of retrievals that my agent makes. So it's not a complex metric and it's not a signal of quality, but it basically just tells me how many retrieval calls that I have. So after running evaluation, I get this clean UI out, which shows me on the this is very similar to a UI you might have seen already if you've been using MLflow, but you basically see your sort of different requests and responses. So these are each different traces, and you can see my assessments over here on the right-hand side. So I can see the number of retrieval calls is on average 3, and actually this guy had 6 retrieval calls, which definitely seems like redundancy. And I can also see my retrieval redundancy judge running here. And I can see in most cases it's actually failing, right? And so maybe I understand, okay, I know I need to make a change to the system prompt, right? I make that change. And then I can actually just run evaluation on the same set of traces with the same scores, just with my new agent. And after running this, I can actually see here that the number of retrieval calls with my new agent has actually dropped significantly to 1.8 on average. And all of my retrieval redundancy judgments are actually passing. So in this way, I've actually verified on a set of actual representative traces that I've systematically improved my agent and I'm not regressing anywhere. And obviously I can add other sort of scores to address other aspects of quality, and I can spend more time crafting specific data sets. A lot of the time we like to think of data sets as sort of like unit tests. And so you're testing different sort of situations that your agent might encounter. But this is a really simple example of how I can use MLflow once I have those traces piped in. And just to recap, all of this is to show you that MLflow makes it really easy to build high quality agents through observability and evaluation. Even though I was showing you guys examples of Claude code tracing and Claude agent SDK tracing, even if I'm using a completely different agent framework, this point of observability and evaluation still holds in that I'm able to actually systematically ensure that my agents are doing better. And MLflow provides different sort of tools that helps you or makes this process way easier, whether it's our make judge interface that allows you to write evaluation criteria in plain English instead of complex code. Or we have this really cool thing called AI Insights, which we might have discussed in a previous meetup, which actually automatically looks through traces, identifies and root causes issues. So all this stuff at the end of the day makes it really easy to build these high quality agents and speeds up that cycle of building these agents. So I'm just going to leave it here. I have a couple of resources listed out here, including documentation for how to actually trace Claude code, as well as the Claude Agent SDK. There's a blog post here which outlines a lot of the stuff I discussed and includes a lot of like additional code examples and little screenshots and snippets. And of course, feel free to leave questions or feedback in the MLflow repository. And as always, we'd love your contributions to MLflow. Personally, I'd love to see tracing integrations for Codex, but I'm personally a big Claude Code fan, so that's why I introduced this one. But yeah, that's all I had. Thank you guys so much for listening in.
Well, thank you, Samraj, for that insightful presentation. Simple yet insightful, and covered all aspects of how you can actually quickly prototype your agent and how you can actually evaluate. Couple of questions that actually came to my mind as you were doing this. One of them is from Ravi, who, as you said, you're a favorite of Cloud Code, and he's popping in and said, "Is Cloud Code the only coding agent supported for MLflow traces?"
Yeah, I think at the moment, MLflow supports 20 plus different agentic frameworks and model providers, but I think Claude Code, and I don't know, that integration page is always changing, so I would definitely check that. But I think Claude Code is the main one that's supported right now.
I think he was probably referencing the way we actually creating the Cloud Code SDK client. Is that something very similar, equivalent with other coding agents like Codex or even Gemini CLI?
Yeah, to my knowledge, I think the Claude Agent SDK is like one of a kind. and that's the only one that kind of allows you to express it in Python.
Mm-hmm.
I might be wrong.
Mm-hmm.
But, all these other coding sort of agents are mostly through CLIs.
Mm-hmm. Mm-hmm.
Yeah.
In terms of your early preference towards cloud code when you're actually doing coding, and you say some of the small tasks you started with, you could also do some PRs, and have you actually developed an entire feature using cloud code for MLflow?
I actually have, and I think a lot of developers on MLflow are using fully automated workflows.
Mm-hmm. Mm-hmm.
It's kind of meta, right? Because we're developing a lot of
Mm-hmm.
agentic features with agents.
Mm-hmm.
Um, Obviously, as I mentioned, there's still gaps and there's still a ways to go.
Mm-hmm.
But I think with the right sort of guidance and supervision, these coding agents are super powerful and they provide production-ready code. I think they're great for small tasks, and obviously for larger tasks, you do have to spend a little bit more time with them.
Right, right. I mean, I'll give you my admission. I wrote my first MLflow coding agent yesterday to write to do a cloud inspect, and all I said was, here's the documentation, here's some Raj blog, and here are some of the most recent documentation on 3.x. Could you write me an agent that allows me to do and use LLM as a judge and use the SDK that he has given it? And surprisingly, 75% of the time, it actually did generate right code. I had to go through a couple of iterations to say, no, maybe you want to do that. Maybe it didn't realize he can actually do autolog. But yeah, I was quite impressed with it.
Yeah, that's amazing. Agents all the way down.
Which leads me to another question. I noticed that you actually, in the CLI, you actually had Cloud Code has actually made a lot easier by just saying, Cloud Code autolog the experiment ID, and you do that, it will generate traces automatically for you. That presumes that you already have a code that you actually ran it, but now you actually want to rerun it to autolog. Is that a correct interpretation?
Yeah,
You can't get the experiment ID without having run the application itself, right?
so I think you can actually just create an experiment in MLflow and link that, even if it's an empty experiment.
Mm-hmm.
But even if you don't configure that, it'll just use a default experiment that MLflow configures to. And the same for the tracking URI.
Mm-hmm.
People have MLflow deployed in certain areas, but if you don't, it'll just default to, I'm not sure what the default is, but it'll default to something, and you'll be able to see the traces flow in automatically.
Okay. Yeah. So you can enable it both on the command line using the experiment ID, or alternatively, you can actually see you can specify that in the code itself as one of the first things after you import spread and say, I want to do autolog everything.
Exactly.
Okay.
Exactly.
All right. So there are two ways to actually make sure that the traces appear, which also begs another question, which is, if I'm using auto.log, do I have to use MLflow start run to make my queries, or it will automatically trace that? In other words, do I have to use the context managers MLflow run?
Yeah, no, it'll automatically flow.
It will automatically do that. Okay. Okay.
And if you specify start run, those traces will actually get tagged with a specific run.
Okay.
So you'll be able to see maybe if you want to group traces together into a specific run, using start run is a great way to do that.
Okay. So you would use start run, and then you actually make your queries inside, and that way you actually get the nested stressing, right?
Yeah, but you definitely don't need it to actually log traces.
Okay.
It'll just log, there's like a little traces tab that shows all the traces in the experiment. So if you don't use start run or anything like that, you just use MLflow Anthropic Autolog, it'll log straight to that tab.
Okay, let me see if I have any more questions that have come in. Yeah, one of the other questions, you were going through the tracing to see why you were actually getting redundant calls, right? So you looked at first call and it was making an airline call. You saw the same thing going, but you actually had to write a judge. You had to call a judge to say, okay, I noticed there were redundant calls and I want you to minimize that. And here's my judge that will evaluate that. Since this is really an optimization of the prompt, because essentially what you're doing, you're changing the prompt so that you can actually detect that. Instead of using a making judge, could you actually have done that using GEPA do prompt optimization, or is that far-fetched?
No, I think it's a great idea. And I love the idea because GEPA is also built into MLflow.
Mm-hmm.
We can use GEPA, and I think you might use it in addition to the judge that you craft or some sort of human feedback that you provide. And GEPA will be able to optimize your agent's prompt, like system prompt, to avoid these redundant retrievals after seeing a human or the judge say, hey, no, this behavior is bad. You have retrieval or redundant retrievals. So go and fix this in the prompt.
So in addition to using the MEC judge, you could also further bolster the evaluation and the strength of the agent by using GEPA to make sure that not only the prompt is optimized, but you also have a second evaluation scorer that actually makes sure that the repetition is not done. Brilliant.
Exactly.
I'm looking forward to that. I think with that, we'll end your session. Thanks a lot, Samraj, for the wonderful discussion. I'm looking forward to go run with your blog and do my second part of the bit.
All right, everyone.
All right, thanks. And now we actually have Yuki Wanataba. He's one of the project lead on MLflow of the open source team, and he's joining us all the way from Japan. Welcome, Yuki. Say hello to the community.
Yeah, thanks so much for the introduction and the great session for Claude tracing. Yeah, I'm Yuki. I'm a software engineer in Databricks. I'm leading the MLflow OSS right now. And yeah, today I'm going to talk about more on the depth in tracing and how to go beyond libraries or frameworks that's supported by us. So how to plug your favorite language or favorite framework into MLflow. Yeah.
All right, take it away.
Yep.
One thing I want to mention, do you actually have any animations?
Let's see. I think I don't. Yeah, all the attachmented pictures. So yeah, I think
okay. Yeah, as long as you don't have animation, you'll be able to just forward the slides. If not, then you can actually share the screen, and you don't have a demo, so we're fine. All right, go for it. Thank you.
Sound good. All right. So yeah, today I'm gonna. Sorry, let me just. Sorry, it's a bit acting slow, but anyway. Okay, so today I'm going to talk about the full OTEL support for tracing, and which is about so starting from a recap, right? So MLflow tracing. So I think Samraj already showed this kind of like some demo of tracing, but let me just start from the very scratch. So MLflow tracing is observability feature that allows you to capture LLM calls, mod rugs, or agents, or any general application and see what's happening inside. And for instance, this is a trace for LangGraph, which is a bit more complicated than Claude SDK in general. But yeah, from the left-hand side, you can see what's happening in the execution in hierarchical view. For example, you have LLM call in blue, tool call in red, highlighted with nice icon. And on the right side, you can see the input-output messages, and also tools passed to the LLM. And also at the top header, you can also see token count and entire latency. So trace gives you visibility into those important insights in the agent execution. And I don't find the, okay, ready. It is just come out. All right, cool. And also another important capability supported by trace is assessment or annotation. So each trace in MLflow carries a list of annotation objects called assessments. And in this picture, we have 4 assessments: overall, similarity, correctness, relevance. So assessment is a container for all kinds of this annotation, including user feedbacks, quality scores, or ground truth even, and let you track those values with metadata. For example, the rationale behind the score or source information about like who added that annotation. It might be human annotator or it might be LLM judge. And so trace becomes a single source of truth for managing those like annotation as well. So you don't need to manage like many spreadsheets tracking like quality of your like execution and version. So MLflow takes care of that. Can we choose the next, right?
You can just use the right arrow key to advance.
Okay, right arrow key.
Yeah.
Cool. Yeah, I was trying to find the widget which somehow shows up when I click the right arrow. Okay.
Yeah.
I found it. Thanks.
You're welcome.
Yep. So yeah, and as Samraj also shown a bit, so evaluation is well integrated with tracing MLflow. So by using the GenAI evaluation capability, you can evaluate local predictions or even production traces or any trace stored in MLflow with a single interface, and you can see a rich result like this. And when you find any issue, for example, there's a field failure in this picture, then you can click on each row to see the traces and pinpoint what's happening there and root cause there. And so I just want to introduce some cool new feature we introduced in the 3.6, which is not directly related to the topic of this talk, but since 3.6, LLM Judge start to show the cost and trace. So when you run the LLM Judge, traces, each assessment produced by the judge will have these two small field. The one is cost. So this is like $0.001. It's cheap because it's using OpenGPT Mini, but it might be higher if you're using GPT-5 and or Claude, Sonnet, or Pass. Or then you can also view the trace from the LLM execution, so you can see input prompt, output prompt, what kind of values are passed there for simple LLM judge. And also, if you're using agent as an agentic judge, which is like more complex and sophisticated judge we offer, you can also see how it behaves with the other steps, so calling LLM, using some tools, and finally come up with some scoring. So this feature gives you a lot of transparency over what's happening inside the judge and allows you to maintain the quality versus cost trade-off for scoring. All right, and last but not least, tracing is a great way to do production monitoring. So this picture is from Databricks Managed MLflow, but this dashboard, and yeah, this is a built-in monitoring dashboard in Databricks. A similar dashboard capability in OSS MLflow is in roadmap, so please stay tuned. But basically, when you have trace enabled in your production system, you will get some this kind of visibility into request count, latencies, and also quality metrics if you set it up. And of course, you can dive deeper into each production call by looking into each trace. So yeah, so all of these capabilities sums up into this picture, which is something called evaluation-driven development. We highly recommend for you guys to build when you want to build high-quality, robust agent. So when you have trace enabled in your app, you are already ready to enter the full LLM ops stack and start iterating on your agent with more confidence and speed. So once you have built a first version of agent or first prototype of app and enable traces, you can use it for manually checking the quality or maybe asking subject matter expert or stakeholders to do review. And you can iterate quick using those manual labels. After you get more traces, you can enter to systematic evaluation using automated judges and MLflow GenAI Evaluate API to get more scale and efficiency in the process. And once you iterate a few times and get more confidence in the quality, you can ship it to production and enable tracing for monitoring. And those traces from production system is a gem. So it is real customer evidence and includes all the rich information about what kind of questions are asked, how agent behave in production, and how satisfied users are. So this is a pretty good source for the data set to iterate on next phase. So you can collect those logs and start fixing issues and start a brew side of loop again. So trace is a fundamental data carry in this loop. And so it is very important to let developers ingest trace for every or for many frameworks or whatever favorite framework like LangGraph, LangChain, OpenAI, or even Claude Code SDK, then it unlocks all the way down of the MLflow offering. And coming back to the topic of this session, so OpenTelemetry. So what is OpenTelemetry? So OpenTelemetry is a de facto standard for software observability. It is a set of specifications and protocols for traces and some low-level SDKs to instrument applications. So OpenTelemetry is what actually drives MLflow tracing under the hood. So MLflow SDK is a kind of wrapper to let you instrument libraries in one line of code and also handle all the complex configurations about OpenTelemetry. And OpenTelemetry is the name as the name indicates, it's very open, so it's not coupled with any vendor or any tool or programming language. So this is a very great fit for MLflow because we also have like that open in mind. Like open source is number one priority for us. Yep, sorry, I think I forgot to proceed, hit the right arrow, but anyway. Yeah, so this is how our SDK actually works under the hood. So we have all the libraries we support here, like not all, it's not exclusive. I think 5 or 6 libraries are missing, but yeah, DeepSeek, LangChain, LangChain, Open, blah, blah, which it can be captured with this single line MLflow.library outlog. MLflow SDK handles all the complexity under OpenTelemetry and produce OpenTelemetry traces, which is basically a trace that have the format that OpenTelemetry defines and exported via the protocol that OpenTelemetry defines. And 1.5 years after first launch, we added this kind of bunch of framework support, and tracing is now used by many thousands of developers and enterprises. So which gave us the confidence that the choice of like openness here really was right decision, which is great. But at the same time, we start to hit a wall a bit because MLflow is mostly written in Python, and we offer similar SDKs like Trace, TypeScript, and Java or R, but it's not sufficient for all use cases. So this stage, AI ML is very popular and even more popular than 5 years before. So many applications outside Python or TypeScript, like Go or Rust or C++, start to use LLMs and want to have same parity as a Python support. So this is one common request we got. Another common request is that since OpenTelemetry has been there for a while, people have system already instrumented with OpenTelemetry SDK, not MLflow SDK. So they wanted to ingest traces in MLflow, but they don't want to migrate entire code base to use MLflow SDK, which is totally reasonable. Another interesting aspect is that, so we support more than like 25 or agent framework, I didn't count, but it's still nowhere close to everything. So there are literally hundreds of LLM agent frameworks over there. So it is practically impossible for our team as MLflow maintainers to have support for all the libraries there and maintain them. So we sometimes hit a wall of, okay, so my agent is not supported, could you prioritize? And we don't have resources to do that. And we have been discussing about these limits for a while, and the answer is actually simple. So let's double down OpenTelemetry. So here's what the idea of full OpenTelemetry support coming to life. And from 3.6 release last week, I think 2 weeks before, 2 weeks ago, MLflow now becomes fully compatible and interoperable with OpenTelemetry tracing SDK. So what does that mean is, so TLDR, you can now ingest any OpenTelemetry traces into MLflow, regardless of who, how, which language traces are generated. So of course, it includes the native MLflow integration just shown in the left. So you can keep using the existing MLflow.something.outlog to use LangGraph or DSPy or any supported libraries. And then another set of new integration the OpenTelemetry support introduced is the frameworks who already have built-in OTEL support. For example, Google SDK, Google Agent SDK, Microsoft Agent Framework, Agno, and also TypeScript frameworks like Mastora or Versa AI SDK. They all have OpenTelemetry native support built in. So without any configuration in MLflow side, once you enable that OpenTelemetry and set up destination, you can see those traces in MLflow and start using it for evaluation, optimization, which the other features we offer. And the third group is other languages. So OpenTelemetry is not language specific. So you can start using Java, Go, C++, Rust, any language supported by OpenTelemetry and ingest traces into MLflow. And not just only ingest, but MLflow also understands the popular semantic conventions. Semantic convention is basically how data is named in OpenTelemetry, like metadata. So, for example, how LLM prompt are stored or how response is stored, what is the keys to store token counts. So MLflow understands popular standards. So even if it's not MLflow SDK, those third-party kind of OpenTelemetry traces are treated as first citizen. You can see token counts, you can see latencies, you can see input outputs in the same way as MLflow traces. So this does solve the limitations we introduced in earlier. So now you can use any languages like Java, Go, C++, and you can use MLflow to get traces from existing application with OpenTelemetry. And also we can integrate with more and more frameworks because now we are not limited by bottleneck with our own development speed. And how to set it up? So this is very easy. You just need to start one MLflow server just as usual. You might already have one. So you can use MLflow server. And the important thing is you need to use database backend, SQLite or Postgres, which we highly recommend as a kind of more reliable setup. Or you can use Docker Compose app. We have a Docker Compose config in our GitHub, so you can use it to spin up a full stack MLflow server with Postgres backend and MinIO artifact store. Once server is up, you can configure the environment variables to send OTEL trace to there. So you can set up you can set the endpoint environment variable to tracking server URI, and also headers. You need to set experiment ID in the header so that MLflow can know which experiment the trace should go. But this two is pretty much all configuration you need. And then if you start the agent or application, trace will start to come into MLflow. I have a few example implementation and trace screenshot here. For example, Google ADK. This is very simple agent. The screen might be too small, but yeah, just set up the OpenTelemetry as usual with those environment variable, and you get traces like the right side. You have the LLM code captured, tool code captured, and yeah. Also, another interesting example is Versa SDK. So yeah, if you have a Versa SDK in your next year's application, you can just enable OpenTelemetry tracing with the single call register OTEL, which is a very useful utility provided from Versa. And yeah, then you have a trace like the right side. So again, MLflow understands the trace structure. So you have LLM call highlighted, messages displayed in a rich UI, and yeah, you can start debugging, monitoring, evaluation using it. And also, OpenTelemetry provides a very convenient sidecar, which is called OTEL collector. So this is a middle layer between application and OTEL backend like MLflow server. It handles retries, batching, PII filtering, sampling, a lot of kind of sophisticated functionalities to make tracing reliable and stable. So you can now plug this in between your application and MLflow to make it more scalable in production. All right, so that is basically all about the OTEL support. I highly recommend you guys to visit the new OpenTelemetry documentation to see that in action and also learn more about tracing and evaluation more. And also check out our blogs for learning new cool features like this. And we also have quite a few new features like agent optimization with GEPA or yeah, whatever. And finally, please give a staff work up at GitHub that really motivate us and give us energy to hard work and shape more and more features. So please give your love to the team MLflow. So I think that wraps up my session. So hand it over to Joel.
Well, thank you, Yuki, for that wonderful presentation. I'm super excited about the ability now to be completely language agnostic and ingest as much data as possible, and quite easily by, as you say, just changing one particular config. I was actually quite drawn by, let me see if there's any questions. I was quite drawn by your first slide where you actually showed the cost of how much it actually takes for you to trace. And I think a lot of people do want to know, both during prototyping and also in production, how much does it actually cost to run a particular trace or to run a particular query. Now, is that cost per span or is that a cost per the entire trace?
Yeah, that is a cost for entire trace. But if you want to dig deeper, the span captures metadata in like attribute tab.
Right.
That's your breakdown of cost. You can also track it.
Okay, yeah, so you can. So if you wanted to find out what span is costing us more, we could actually further go down into the individual span to compute the cost. Exactly. And the way you compute the cost is just taking the number of tokens for the entire trace and multiplying by per token price. Brilliant. I like that. I think it would be nice to actually have the ability to say, per span here are all the different costs, and then give the cumulative cost, because a lot of people, especially when they write multi-span, multi-flow agents, they want to somehow find out where is the bottleneck, right? Which part of the multi-flow agent is costing me more? Is it parsing a PDF document, or is it just taking the parsed document and then generating a summary of that? I think that would be good.
That's a very good feature request. So yeah, we should definitely consider that. And also, yeah, I know like sometimes people are using GPT-5 for some part of workflow.
Yes. Because especially when you're building multi-flow agent, you're probably going to use one model which is suited to do X and the other model suited to do X, Y, and Z. And you somehow want to decipher or delimiter, what part of the span is actually costing. It's good to do those post-mortem analysis.
Yeah.
Let's see. The question I have is, when you enable open telemetry, ingesting data, and you also have MLflow Autolog enabled, are the traces interleaved? Can you distinguish that one is coming from the open telemetry and the other one is generic MLflow traces, or are they logged separately and there's a different UI you actually go through that?
So if you enable it in a single application, so you enable OpenTelemetry and MLflow SDK in both applications, there will be single trace. There's one configuration we need to enable, the environment variable, to say like, oh, please use both, kind of like environment variable. But once you enable that, the both OpenTelemetry and MLflow SDK create a single trace, which you can see in the single UI.
Okay, but you can tell the difference between one is coming from OpenTelemetry and the other one is.
We don't have a like label of, okay, so this is OTEL, this is MLflow. But if you see the attribute and input output, you can clearly see that, like with the attribute name, for example, MLflow uses attribute name like it's just normal attribute name, but in OpenTelemetry they usually use like GNAI.llm.blah blah or some sort of naming convention, so you can see the difference from there.
But the format is the same in terms of the way it's actually laid out.
Yeah, exactly.
The other question was, I looked at the slides and I saw most of the telemetry example you were actually giving were on the local host. If you're actually running, say, MLflow server starting with the SQLite background, you're going to run on your backstore on port 4000. But what about people who in production or semi-deployed environment who are using a remote server? How would that actually work? So your endpoint now is not your local host, but your MLflow server that you have either self-hosted or you're using, say, for example, managed MLflow from Databricks. How would that actually work? Can they remotely from a client go ahead and do the telemetry to that particular server, both using MLflow as well as using all the other SDKs which are not Pythonic or which are not language agnostic? How would that work?
Yeah, that's a great question. So if you have the database backend already and running in 3.6, you just need to change the endpoint URL to that like host server. It might be your company's internal URL or maybe SageMaker or whatever URL. And also Databricks Managed MLflow already support OTEL as well. So if you are using Databricks, you just need to point it to your Databricks workspace and it will automatically understand the open telemetry workflow. So yeah, just remote and just the same as a local server, but just make sure you run it in 3.6 and also with database backend. So that is the only two prerequisite.
Yeah, I get an acknowledgement for to you, and both Pierre Debois say thanks a lot for asking about the cost can be broken down by span. So there you have a feature request right live from our MLflow webinar. So this is exciting. This is great. If you guys have any questions, please do pop in. What do we have? Okay, we have another question from Ravi, who has been very active this afternoon. Does OTEL Trace need to support semantic conventions for generative AI system to be used in MLflow? And maybe you might want to somehow explain what he actually meant by semantic conventions.
Yeah, I think I know that. Yeah, so basically, so the answer for this direct question is no, it doesn't need to be. It's so nicer if it's conformed to the convention. But just for the other audience, like the semantic convention here is basically in OpenTelemetry, you have a list of attributes in the trace. So basically key value mapping of, okay, this is, for example, system ID something, session ID something. So this kind of attribute. And for GenAI, OpenTelemetry defines official convention that, okay, so if you want to store LLM prompt in trace, use this key of GenAI.LLM.prompt or something. And for token count, use this. So MLflow understands that and render it nicely. For example, if you have token count with key defined in semantic convention, it will show up in the header as a token like field, and it will also like show up in the like other expand. But yeah, so it is more convenient if you have that. But even if it doesn't, MLflow still show the trace in UI, span in UI, and also you can see all the attributes in the attribute tab. So it doesn't block, like the semantic convention is nice to have. It doesn't block you to plug in your existing AI system to MLflow.
Well, thanks a lot, and I hope that that addresses the curiosity, Ravi's, and he was actually quite forthright in acknowledging that this is actually good news, especially using MS Agent framework in Java and C Sharp, as well as Google and ADK for Golang. And I think this ability, in my opinion, for being able to actually be language agnostic, to be able to ingest data in MLflow server and then look at it. So people who are not familiar with MLflow or are not Pythonic, using their own particular SDK can still actually do the tracing valuation using the open telemetry. I think this is definitely a huge way to grow the ecosystem, that it can be actually accessed by other SDKs.
Yeah, absolutely. Speaking of the language agnostic, we also trying to make UI more rich. So you can, in after this quarter, you will be able to even run those LM judge from UI or maybe prompt optimization. So that you don't need to do evaluation from Python. So you in the end of the year or maybe next January, that world that you don't even need any Python to use MLflow. So that is one of our kind of vision right now. So.
Okay, Pierre wants to know, and I think this probably would be a good way to finally ask the last question because we are almost in time. Are there any coming updates? Well, Yuki is the right person. Are there any coming updates to the MLflow package that supports MLflow in R that relates to trace features? It allows the user to present the interface, and R has an LLM package for AI development in its environment. Thank you.
I see. Yeah, that's an interesting
Yeah,
aspect.
yeah.
To be honest, we weren't really aware R has LLM specific packages. We kind of know there is, but we didn't know like how much popular was that. So Prisma is a PR FR in the repository, and I believe if the library already supports some sort of open telemetry, we can easily plug it into MLflow. we might have a bit challenging time if we create full stack MLflow out tracing SDK. That will be a huge invest, but we can consider and we can find out what's the best middle ground there. So
good. Well, there you go, Pierre. You got your answer. But if you're extremely curious about it and want to make sure, maybe you can actually file a request for enhancement, and that way it's sitting on our stack, and then we can start looking at it. And as more and more people give vote to say, yes, we are R programmers, we are original diehard data scientists, and we do want to use R for our MLflow tracing, then that will definitely motivate us to do that. I don't see any more questions. I think we're almost coming to an hour end. I want to thank Samraj, and I want to thank UK, and obviously my esteemed program manager here, Carly, for today's sessions, and all of you joining us from different parts of the world, taking the time to join us. Again, we have the resources. Please do follow up us on the MLflow YouTube channel. This is going to be recorded, and we're going to be broadcasting, and you can share it with your friends. And please do join us for the office hours next week in Asia Pacific time. So if you're there, there'll be more MLflow engineers who can ask anything about MLflow.